got one more hypothesis test for standard deviation. Again, you can tell that this question is a hypothesis test because in the last sentence it talks about the level of 0.05. So we're going to go through those 6 steps of hypothesis test. If I can. So stating my hypotheses. And it talks about the College Board's claim that the standard deviation, so we know we're going to test the standard deviation. We're testing it against 110. And it says is 110, so that'll be equal, which is the claim. So then not equal to will be the alternative. So for my picture, we again have that right skewed curve. In this particular case, it is two-tailed because the alternative is not equal to. Now, just like before, when it's two-tailed, I need to stick a label on, but I don't know whether it goes on the left or the right, so I'm just going to guess that it's the right, but I may have to come back and change that, and that's okay. So for my test statistic, we have this formula. Oops, over sigma squared. And we know in this particular case, N, it says that there were 15 applicants, so N minus 1 is 14. S squared, the standard deviation from those 15 applicants was 100. So we square that. Divided by sigma squared, that comes from the hypotheses, so 110 squared. And we get 11.57. Now, this is the one thing that is harder, and it's the one reason why I wanted to do a two-tailed test with standard deviation. Here at this point, if we were doing means or proportions, if we got a negative number, we would just move that critical value in our picture over to the left-hand side and be done with it. Or if we got a positive number, we'd make sure it was on the right-hand side. That is not as easy to look at with standard deviation and variance or with the chi-square distribution. So 11.57 is our standardized test statistic. Instead of looking at whether or not you have a positive number or a negative number, you're going to compare this to the degrees of freedom, which in our example was 14. So since 11.57 is less than 14, we should be on the left-hand side. If we had gotten a number that was bigger than 14 or whatever the degrees of freedom were, we would put it on the right-hand side. So to find my p-value, since I moved the chi-square, it tells me that I don't need the complement rule. But since it is two-tailed, I still need to double it or multiply by 2. So we get 0.7185. Which is way bigger than my level of significance, so we should fail to reject. null. So my decision we're talking about standard deviation, not mean or proportion here. And we took the standard deviation of, this was SAT scores that we were measuring. Of all. Now, I think this is a good example of where you should be careful about just slapping down a word. This is not of all people that take the SAT. These 15 applicants were randomly selected from the admissions at one university. So that's not of all applicants. So that's just of all applicants to this particular university. Could be the null, which was 110. So this means the claim could be true. So as I mentioned earlier, I picked this one because it was two-tailed, and that does make it a little bit harder for the chi-square distribution. Also, I thought it was interesting, as we talked about in the serial example before, that many times quality control wants a very small standard deviation. In this particular instance, they want a particular standard deviation. They don't want it too small because then everybody would all be jumbled up in the middle with SAT scores. And they don't want it too far spread apart, then you'd get lots more people at the extremes, lots more people scoring the highest and the lowest, and they don't want that. They want it somewhere nice and in the middle. So that's what this example is supposed to be an example of. As always, if you have a question, please ask your instructor.